Five identical condensers are connected as shown in the figure. If the effective capacity between A and B is 6 microfarad, find the capacity of each condenser. So in the figure there are 5 condensers connected and equivalent capacity between A and B is given as 6 microfarad. Then what is the value of individual? Right? Let us consider capacity on each one is C. And our aim is to calculate C only. Let us take this point as P, this point as Q. Now let us redraw the figure. One side I am taking A, the other side I am taking B. This is A, this is B. Now start from A. A to P, one capacitor is placed. This is P. At P, wire divides into two parts. So take this part, connect a capacitor, and to this another capacitor is connected, and this is taken to another point Q. So this is P, this is Q. In between I am moving in the clockwise direction, so I got two capacitors. Now between P and Q, anti-clockwise direction, only one capacitor is present, and between Q and B another capacitor. So these two figures are same. Here starting point is A to P one capacitor, put a capacitor. Between P and Q I can move clockwise as well as anti-clockwise. First move in clockwise, C and C in series. To that C is connected in parallel, and between Q and B another capacitor C. Now let us consider this value. So what is the value there? C and C in series, so equivalent becomes two equal capacitors are connected in series, so equivalent is C by 2. This is our A, this is our B. Now C by 2 and C are connected in parallel, so equivalent becomes 3C by 2. In parallel combination it is the sum, C plus C by 2. So this is C, this is B, this is A. Now all the three are connected in series. The equivalent capacity between A and B, 1 by C plus 1 by 3C by 2 plus 1 by C. The equivalent capacity in parallel combination. So I can take 1 by C common. 1 plus 2 by 3 plus 1. So 1 plus 1 is 2 plus 2 by 3. So this becomes equal to 8 by 3C. Therefore effective capacity between A and B is 3C by 8. This value is already given. The effective capacity between A and B is 6 microfarad. So substitute this as 6 is equal to 3C by 8. Now with the 3 it is 2 times. Therefore C is equal to 8 into 2, 16 microfarad. The equivalent capacity, since it is 6, the value of C is 16 microfarad. So just from the figure, 5 capacitors are connected like this. So each one let us say C, and these junction points I am taking as P and Q. More than one wire meeting, two wires meeting, then normally it is considered as a junction. Here there is a possibility for a division of charges. That's why this is taken as a junction, this is another junction. So I am redrawing the figure. One side I am taking A, another side B, P and Q. Between A and P put a capacitor. Between P and Q, two capacitors connected in series when you move in clockwise. In anti-clockwise only one capacitor, and between Q and B another capacitor. Now I am simplifying this one. First I am considering these two, C and C in series, so equivalent is C by 2. Now this case these two they are in parallel, C by 2 and C parallel, equivalent is 3C by 2. Now these three are connected in series between A and B. Therefore 1 by CAB, simplification gives CAB is equal to 3C by 8. Since CAB is already given as 6, therefore C becomes equal to 16 microfarads.